In question 2, we're told the nucleus of a particular atom has a nucleon number of 14 and a proton number of 6. In A part 1, we need to state what is meant by nucleon number and proton number. Well, the nucleon number is the number of protons and neutrons, whereas the proton number is just the number of protons. In part 2, we need to find the number of neutrons in the nucleus of this atom. Well, the number of neutrons is equal to the nucleon number minus the proton number. 14 minus 6 gives 8 neutrons. In part 3, we need to find the specific charge of the nucleus. Well, the specific charge is the charge divided by the mass. The nucleus has 6 protons, each with a charge of 1.60 times 10 to the minus 19 coulombs. Taking the mean mass of a nucleon as being the atomic mass unit, we have 14 nucleons at a mass of 1.661 times 10 to the minus 27 kilograms each, giving a specific charge of 4.1 times 10 to the 7 coulombs per kilogram. In B, we're told the specific charge of the nucleus of another isotope is 4.8 times 10 to the 7 coulombs per kilogram. In part 1, we need to state what is meant by an isotope. An isotope has the same number of protons but a different number of neutrons. In part 2, we need to find the number of neutrons in this isotope. Well, the specific charge is equal to the charge, which is 6 times the charge on a proton, divided by the mass, which is the number of nucleons, which I've called A, multiplied by the atomic mass unit. Rearranging for A gives an answer of 12 nucleons. The number of neutrons then is the 12 nucleons minus the 6 protons, leaving 6 neutrons.